Hello, everyone. Let's get started. Please download Laboratory 25 from Blackboard. And today we are going to learn confidence intervals. As usual, please run the first script to identify your hostname, username, and kernel information. And next one, please input your name, or a number, and title. Okay, let's start with the example. Actually, in this class, we will learn only this example, but for different numbers. Okay, so this example is from a normally distributed population, randomly took a sample of 500 students, and the mean value would be 461. And then suppose we have a standard deviation of the population is 100. Then we want to know what is the population mean for 95% confidence interval, right? Because it's a population, it's a randomly selected, right? So although the mean value would be 461, but not all numbers, they are 461, so they are distributed around this mean value. That's why we need to set this confidence interval, right? So first, we need to organize the data. So first one, the sample size would be 500 because we have 500 students, right? And second one, X bar means the sample mean means the mean value, and next one is the confidence interval, right? The C means confidence level, 0.95 standard deviation here, right? And next one is Z value. Z value is associated with 95% confidence interval, right? It's also this one. And the next one we need to like so if you are not familiar with the Z value, you can just Google it and then learn. It's only related to this confidence level. Okay, so this is determined by this confidence level. So for now, we have 4 different numbers, different variables: sample size, mean value, confidence level, and standard deviation, right? Next one, we need to compute the margin of the errors. So around the mean value. So we need to import math and compute the margin Z multiply standard deviation divided by square root of number of square root of n means the sample. And after that, it is margin of error is equals to this one, right? And after that, we need to find the range of the values. Have to add and subtract the margin, right? So the low would be X bar minus margin, and high would be X bar plus margin. And then the result would be like here 452 to 469. So it is but the example, right? The result for this example for 95 confidence level interval, it means the true population mean will be captured within this range, and the confidence is 95%. Okay. All right. So any questions, or do you have any errors? We'll run the cell. Okay. Next one. So what is the population mean for 90% interval? Actually, it's very, very similar. Actually, we need to organize the data again, right? The sample size, the student's number, 500, X bar is the same, but the confidence level is different. Here, C is 0.90, standard deviation is 100, and Z value, sorry, this is 90 confidence level, right? So Z is smaller, and next one we need to calculate the margin of error. You can copy from the last example and actually organize the data again, run again. So the margin of error is smaller, and the result is the same. But the last one here is a 90, not 95. So it is a result. Okay, so yeah, so to be honest, the last two cells are exactly the same, right? Because it's the same to calculate the margin of error. It's the same to calculate the range of the values, right? The only difference is when you organize the data, different confidence level, right? So in this example, because the z is smaller, then this is the same, and z is smaller, so that's why margin would be smaller. It's 7.33 is smaller than 8, right? And the range of the value is smaller, right? So it's only 90% confidence level. Okay, so it is for the second example. And next one is 99% confidence interval. So first organize the data. The only difference is the confidence level here is different, right? And z value is different, but the last two, they are the same, right? So calculate the margin again. And calculate this one again. So it's larger, right? 11. And for 97, for 95 is 8, right? So as a result, it is the range of the values. It's larger, right? So this is the largest among the 3 examples. Okay, it's for the 99% confidence interval. So please do it by yourself. You can copy or you can write it. What do we need to change? So the first is about organize the data, right? And second one is the same. So it's the same to calculate the margin of error. And the last one, if you want to copy, you need to make sure here the confidence is different, right? Yeah, only this one is different for the last 2 cells. Okay, and please answer this question in your own words. What's the relationship between the confidence interval and the margin of error? Here you can use this one, right? The margin of error is a z value. Z value is determined by the confidence interval, right? So it means when the confidence interval is larger, then z value would be larger, and the margin of error would be larger, right? So it's a relationship, but please write your own words, okay? Yeah. So next example is it's the same example, but with different variables, right? So here, solve the above problem, assuming we have a sample from 1,000 students. So first one, organize the data, but here is a different, the number would be 1,000, okay? So you can copy from the first example, but please make sure here, this is a different. So copy again. Copy from the second one. Oh, sorry. And the third one from the first one here. Okay, 95%. Yeah. Run again. So the margin would be smaller. 95%, right? So compared with the first example, the only difference is about the number of students. And because when you calculate the margin here, you need to divide the square root of the number. So that's why here the sample size is bigger, then the margin would be smaller, right? So margin would be 6.1, and in the first example is 8.7. So it's a different. And the last one would be here, 95%. Okay. All right. So any questions so far? And second one here, the native confidence interval. So you can copy from this one, right? But please make sure you set is 1,000, right? And C is 0.9, and the Z value would be 1.6. Okay, so and for some other things, you can copy this one and step 3. And please make sure to revise here. It's 90%. Okay. The margin will be smaller, right? Margin will be smaller. It's for the 90% confidence interval, right? And after that, so next example, 99 confidence interval, can use this one. Oh, sorry, not this one. This one, right? So 99, C is 99, and Z value would be 2.5. 1,000. And here 1,000. Right. Oh, sorry. The last one would be 99, but the result is correct, right? It's the right one. Okay, so it is for the solution for 99% confidence interval. All right, please do it by yourself. You can write it or you can copy, but please make sure you revise the sample size here, and this one is different, right? So for the first 6 examples, they are very, very similar. The only difference is how you organize the data, right? And the next one, you need to answer 2 questions. What is the relationship between sample size and margin of error? What is the relationship between the sample size and confidence interval, right? What's the first, these 2 exercise? Answer it by yourself, right? And next one, solve about assuming the standard deviation of population is 50. So with that, we have 4 different variables. So we change so the mean value is constant, but and then we changed all other things like the sample size, confidence level, and in these 3 examples, we changed the standard deviation. Okay, so you can do that again. You can copy the second step and the third step. Okay, the third step. Okay, so you can copy, and the last one here. $1,000 mean value is the same, standard deviation, and not confidence level and standard deviation here. And calculate the margin of error. It's very small, right? Because it's Z value multiply standard deviation divided by the sample size, right? And after that, the result would be 95%. It's very, very small, right? Because in this, when you calculate the margin, you need to consider the Z value. It means you need to consider the confidence level. You need to use the standard deviation. You need to use the sample size. That's why it matters. So if you change the X bar, it doesn't matter for the margin of error, but it will affect the range of the values, because you need to use X bar to minus and subtract and plus the margin, right? All right, so it is for the 7th example. Population, the standard deviation population is 50, right? And next one here, for the 90% confidence interval, I will show you, you need to do that, copy from here, right? 90, and then standard deviation is not 100, it's 50. It's 50. And last two, so you know how to do that, right? Please finish it by yourself, last two. And for the last one, organize the data, 99%, right? Okay, so 99% here. And you know how to solve the problem, right? And what's the relationship between the standard deviation and the margin of error? So you need to finish the last two examples and answer last two questions. What is the relationship between the standard deviation and margin of error? What is the relationship between the standard deviation and the confidence interval? Okay, you can answer by this one, right? You can use this one. It's a hint, right? Okay, so what is? Yeah, actually, it's the same thing. So like, the only difference is how you organize the data. So that's the three example. You have different standard deviation numbers, right? But for the steps 2 and steps 3, they are exactly the same. Okay. All right, and answer the last two questions and the last exercises. So why are confidence intervals so useful? You need to answer it by yourself. If you use some resources, you need to set them. Okay. All right. Please finish them by yourself and submit it by next Monday, the end of next Monday. All right. Okay, that's all I want to share today. And have a nice day. Have a nice weekend. Thank you, guys. If you don't have any questions, you please feel free to leave the meeting. Well, thank you.